From ContainerDays Hamburg, this video is proudly presented by Dux IT.
About my 2 years with GitOps with Flux in production, So the QR code, there are my contact data. So if you want to contact me afterwards, I'm here from. It's the wrong. I hope it's the right. It's the right one. Okay, I'm here near from Rosenheim. It's in the south of Bavaria. So I want to start. Project environment. We are in a project where we build the after-sales information systems of a German automobile manufacturer from Bavaria, and we have up to 5 development teams at the peak time, and partly some of them know about platform engineering, some without. The next point I will skip because it's not so important. Then we have 3 applications, and we have 3 hubs, one in the US, one in Europe, Middle East, and one in China. And of course, we have 3 stages: 1 integration, which is our test environment, 1 QA, and 1 production. In total, we have 10 Kubernetes clusters. So we are a small team, and of course, our development teams who build the application also run the Kubernetes clusters. All service processes in the dealership from this automobile manufacturer run over our platform. So if you came into a car workshop and you want to repair your car, so the first point where you came into contact with our software is you hand over your keys, and the keys get read into our system, so we have the first diagnostic information. We have around 15 specialized deployment units, but not every deployment unit is in every hub. And in total, there are 100 million requests per 24 hours across all production systems, and the peak is 70.5 million requests per hour. So it's quite a lot, and you can imagine that. If 10 minutes the platform won't work, it has a big impact. How our current existing setup looks like. That's a small example screenshot of our cluster state repository where we manage everything. So you can see it's one cluster state repository, and this Flux is configured on the cluster/hub-stage Flux system, so as every time. And this directory only exists in a branch which is named the same. So the branch is named hub-stage, for example, EMEA int or US QA for the quality assurance environment in the US. All services live under application. So you can see it here. Service A, the customizations, and that's also have the link to the applications Git repository where the Kubernetes manifests live. There's the Git repository, some sealed secret or external secret to get the SSH key for accessing the Git repository, a Flux customization, and maybe image repository or image policy to update the services. And all internal infrastructure components are under infrastructure, for example, the AWS load balancer controller or the Envoy gateway to get ingress into our cluster. Both the controller and the configuration of are on the same branch as of our infrastructure is in the same branch as the Flux infrastructure system, and that has some problems, to which I will come later. Our services have always the same structure. It's mostly templated for 50 services in 5 teams, so we have to template it. The whole general configuration is on the customized base, so mainly deployment config, service account, and so on. And environment-specific configuration is under customized environment and then hub-stage. So you can see it here. And the main reason why we choose this infrastructure or directory structure was that we can patch the base layer with our configuration. So a deployment file in the production environment that only changes the number of replicas and everything is the same as in the base layer. Yeah, local configuration for our tilt setup is also possible. Yeah. Here is a short example of customization which we use, and there is the link to our base layer of every service. How look our deployment process? FluxCD polls every service repository regularly. Most services, we have an interval of 1 minute. It's just because we want to ensure that every service always run in the current configuration and you don't have any drifts. And we don't want to wait a couple of minutes until Flux reconciles and deploys everything. On integration and QA, we have image repository and image policies. So Flux automatically updates our images and the customizations, so we can, so we don't have to think about when we deploy any new version to our infrastructure. On integration, each status of main is deployed. So main is every time the current development branch. On QA, only the last Git tag, which is follow Themware, is deployed, and on production, you have to put the Git tag and image into 2 files and merge them via pull request into the right branch in the cluster state repository. Yeah, that's a short example of a Git repository. So, and here is a short example of how our customization work. There's in the 2 last lines the automatic image policy, so Flux can update everything. Yeah, does it work? A question I was asked many times, or I asked many times to my teams after they or during a deployment, and mostly, no, sorry, but we don't net where the error is. Yeah, that's a small problem. sometimes, or like bigger. And the reason is why that errors can appear in various places. And for this, we want to take a short look into how Flux reconciles everything, and and that's and there it gets clear where the errors can occur. So first we have our source controller, and the first thing it does is to read the Git repository. In this case, the Git repository of file Flux system, and reads the information where it can access this Git repository. And of course, it reads the secret with the SSH key. Yeah, if your SSH key is not there, it cannot pull the Git repository and will fail. So it will try to read the Git repository or the head branch, the head commit of that Git repository, and then it stores it in storage it called artifacts, and then the customization controller comes in and it reads the customization Flux system. So there's described which Git repository it should read and where it finds the main entry to all manifests. So it reads the artifacts. Hopefully it is already there, and then it runs a customized build, just normally customized build as you can do with kubectl apply -k. Then it runs a dry run, and of course in a dry run can produce errors, and Flux the customization controller will stop. And then it will apply the changes. So typical places where error can occur, we have some errors already seen in the diagram before. So the Git repository, it cannot be pulled. Secrets and is the repository URL correct? Of course, but it happened. The FluxCD customization can be wrong, so the wrong entry point and so on. Or customization build errors. So you have the same resource with kind name and namespace in it, and because of copy and paste errors, then you will occur some build errors. That's incorrect or missing resources. Duplicated resources, I already described some. Faulty patches, so you want to patch a resource for a specific environment, and you have some spaces to match, or less spaces, and so on. Or the most error which I occurred was that the cluster state doesn't match to the manifests in the repository. In the most cases, it's because the custom resource definition doesn't exist, or it wants to change immutable fields, for example, the labels. And in Helm releases, there are also source of many errors and faults. In most cases, you have it will be deployed, but the pod won't come up because of the pod configuration. So you have to wait. It runs into the wait timeout, and the pod has a crash loop back off. Next thing, organizational matters. Where does the config map actually come from? It's a small problem, but in 5 teams on our clusters, it is a small it happens. And the reason is Flux itself don't recognize any assignment between the repository and the service or namespace for which it comes. And yeah, so each repository can, in our setup, define any resource and override any other resource, even if it is from another team. And that's a problem which we already addressed, but I will come back to that later. Yeah, with several teams, trust is essential, of course. Then, next. Yeah, we have this entire infrastructure in Git, so we can simply restore it. Or, yeah, in theory, it's true. The practice shows no. Why? Flux always ensures that the current status from Git is also active in the cluster, and that means that it will deploy the top commit, or it will build the top commit of our Git repository using customization, and then it deploys it. So, in most cases, if you're on your integration environment, you build commits incrementally. So you first install the Helm chart with new custom resource definitions. Then you deploy your, for example, HTTP route, because you just installed your Envoy gateway, and that's work. And this can create invisible dependencies between the between commits and, for example, the custom resource definition and the custom resource which uses this CRD. And if you deploy it if you build a pull request to merge these changes from integration to our QA environment, and in most cases, you will create a pull request, and this pull request gets applied as an atomic change to that cluster. So Flux will try to install the Helm chart. Yeah, it is okay, and it will also try to add the HTTP route, but the HTTP route CRD isn't in the cluster, so it will fail. And you think, what have done wrong? So it doesn't work because the CRD is not here. Yeah, the very quite simple solution is you split the customizations into controllers and configuration, and the first customization will add the controllers, for example, the Envoy gateway and all CRDs, and the second one will apply the resources which are using this CRDs, for example, the HTTP routes. It's just 2 lines of code in your Flux customization that's depend on, and with the name of the other customization. Yeah, why I don't want to live longer without GitOps. The first point is efficiency. I applied and deployed a really big monitoring stack to our infrastructure, and with Grafana, Tempo, Mimir, and Loki, and yeah, it was just 2 clicks on the pull request. Merge, yes, I want really to merge it, and the deployment was finished. So it's really easy for everyone to deploy a change into production if the pull request is already prepared. Yeah, of course, you have to create, for example, some S3 storages or so on, but this you can do in the upfront, and then the real deployment is just merging the Git commit. One other thing is that we are that because we have this directory structure where the local test environment is next to the configuration for production, you always see that you have to change some. If you change something in your local deployment, you have also something to change in your production environment. So in this case, it's easy to add the changes directly if you're while developing the feature to think the production environment with. So yeah, you can't forget it, and then it will also go through the review, and yeah, it's pretty simple to think about all infrastructure components. Yeah, and of course you just have to the small differences between in the services between your between the environments. And of course, you have easy reproducibility and traceability. So in general, it is easy to clone the cluster because you have everything in the in your Git repository. But secrets management, yeah, can cause problems. Persistent volumes may be missing or empty. And the surrounding infrastructure may also cause problems because of infrastructure roles for if you're using workload identities maybe are missing, and the managed services. But rollback is always possible, and it is very simple because you can just restore an older commit and you're on the previous version. So it's really simple. But you have to take into account that databases and so on maybe change their automatically their schema and so on. In this cases, the rollback may be also fail. So yeah, it can happen. And of course, the other reason, because we have only a reconciliation interval of 1 minute, is it is always clear which service and which version is deployed, because every image update on every environment will get a new commit. So in you push a new commit of a service into your service repository, the GitHub pipeline jumps in, runs it, builds the image, and in this couple of seconds later, the image is committed. The new image tag is committed to your cluster state repository, and it gets deployed. Yeah, typical problems during deployments. Missing PR reviews. All PRs which change anything in our environments must be approved. And yeah, it was most of our deployments were failed in the first time because of the approval of the PR. So yeah, bad team. No, just fun. Second one was customized build errors, as I already mentioned. Matching resources not or incorrect registered, and patches for the environment are faulty, as I already mentioned. in some cases, we have V1 alpha or V1 beta CRDs, and they won't update every time correctly, so it might be also a problem. As far as I know, we don't have any alpha or beta CRDs at the moment in the cluster. So this maybe is now out of time, scope. And yeah, we have external causes in some deployments. Yeah, Outlook. What we want to do next. The first one is we want to do more shift left for our production pull requests. So we want to introduce some pull request checks, which maybe perform a dry run on the cluster, so we can detect some errors before we try to merge the pull request, for example, because of, you have the wrong resource registered or not registered, and that's one reason why we, want to introduce pull request checks. And the next one is that we want to introduce the D1 repository structure. It is from Control Plane. Control Plane is the maintainer of Flux, so they have many experience about using Flux and in small and bigger infrastructures. And the main point of the D1 repository structure is it consists of 3 cluster state repositories. First is the fleet cluster repository, fleet repository, which manages all the clusters and services as the entry point for FluxCD. Then there is an infrastructure repository where it stores every cluster-wide infrastructure, for example, the AWS load balancer controller or the Helm chart to install the Flux Envoy gateway. And there's a third application repository which maybe can multiplicate it for each team, which stores the Kubernetes manifests for each service in the cluster for which the team is responsible. And it maybe leads to a few differences between the branches. That's one recent pain point on our custom infrastructure repository, cluster state repository, because all the environment branches are so drifted outside, so we cannot merge them together because in the one file is just in the one branch, another file is only in the next branch, and a third file has been changed because the cluster postfix has been changed. So that's a problem, and the D1 infrastructure will solve this problem. And of course, it allows to use airbag restrictions per repository. So you can pin the apps repository from the one team just into one namespace. That's a great advantage from the D1 repository structure. Sorry. Here a short example how to add the RBAC instructions. Here is the service account name within, and Flux will use this service account to deploy everything in the cluster. So that's the point where you can restrict a repository to only one namespace, for example. And there's a second point. Flux supports variable injection or substitution, so you can use the same file for each environment, and you don't have to change it because Flux will inject the right application name and, in this case, hub and environment or stage into that Flux customization. Yeah, and the only thing you need is a post-build section and a config map where it takes the variables from, or the values from. Yeah, and that's it. So, do you have any questions?
It's not an unexpected one. What about, have you considered using ArgoCD?
No, because I wasn't in the discussion about Flux or ArgoCD. It was already in the project when I came into it. So, yeah, I had to use Flux.
Okay, I think we answered 2 questions at once by answering that. Are you worried that every developer can change the production folder?
No, because our production branches are protected branches, so you have to create a pull request unless GitHub won't push you something into that branch, and that pull request must be approved, so from a second person. So it is always ensure that at least 2 persons are involved during a production environment.
Okay, that's good. Where are the variables saved?
Yeah, the first is within the environment files. So there you can also extend using a merge mechanism all your config maps and secrets and so on. And it's the first point for the variable substitution. It's a simple config map, and yeah, that's it. I hope I answered the question.
Thank you. Would it not be even better if the basis was in a different repository altogether, to have complete control over what base is used in production?
Maybe, but a part of our services are using the template, and some of them are not using the template. So, yeah, and in an environment with 5 teams, it is not so required that we have everything together. So, you know each other.
Okay, good. And then let's go over to the last question. How do you handle Flux control update in all environments?
There's a GitHub action in the cluster state repository, which checks every week for new Flux releases and creates a pull request, just a simple pull request for every environment. And then you can deploy it in the same way as you deploy every other service.
Thank you, Christian.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.